Okay, here we go. We got the grid dip meter, the Measurements Corp, or actually it's called the Boonton Corporation, New Jersey, model 59 because it was made in 1959. Went through it, cleaned it up, changed the pilot light, cleaned it all up. On this display, I cleaned it all up. It was really, really dirty. I took the whole front cover off, cleaned the little plastic glass, the dowel. I adjusted it the best I could. It's pretty accurate on some of the coils. It's dead nuts on, and you adjust it by sliding the front cover on this the dial thing, so to speak. I did it with the frequency counter built into the scope. This one is off a little bit. I thought it was a little bit more accurate. Some of these coils are dead nuts on. This one had the top popped off a little loose. These were a little bit high. Probably the distributed capacitance changed on the outside. It looks like it has some discoloration that the other ones don't. May have to tune them up. But this one here seems to be pretty close. So I had this coil that I wound a long time ago for a antenna tuner, and here's this little infamous little red molded mica cap that John gave me. He measured 30 puffs on his meter. I measured 28 puffs on my meter, and I measured the inductance of the coil, which comes out to be just about 5 microhenries. So there's my circuit. Frequency is 1 over 2 pi squared LC, of course, and with 28 puffs of the red capacitor and 5 microhenries of the coil, should come out to 13.45 megahertz. And I found out it's pretty close. I did put some parallel resistance in there to make it so that it's not so sharp. It was so sharp you can barely catch the dip on this thing, so I wanted to soften that up a little bit. So here we go. So we are at 12, I think. What are we looking at here? So we're looking at 12 here. So we're going to move that along. I'll turn the meter so we can see the meter, and we'll see where that dips here. Okay, well, there we go. It's starting to dip. It's pretty sharp, but it's okay. Looks like it's going to dip all the way down to there. According to this, these graduations are 2 or 0.5, so that should be 12 megahertz, 12.5. This should be 13 megahertz, and this should be 13.5. And that's exactly where it's dipping, right at 13.5. So we're really close to that. So there's where it dips. And there's the deepest null. Let's see, does the meter read? Yeah, not quite 13.5. So 13.5 would be right there. And it's not dipped there. I have to go down a little bit. So the meter, this little thing is off just a little bit. Not much. No, actually, there's 13.5 should be right there. It's really close. Yeah, right there. We'll call that the dip. And we're looking at not quite. A little less than 13.5. So let's see what the meter scope says. And it dipped, and it is 13.45. Flicker, 13.45, and according to this, that's exactly what the calculation should have been. And you'll see how that when it dips, the amplitude, we're going to get some, the amplitude goes down. Let me get some better trigger here. Oh, let's see here. The amplitude will shrink. Let me change the lighting here. Let's see where it dips here. Get it to dip here. Oh yeah, sure. Okay, so there's the dip. Okay, so there you have it. There's the dip. Almost 13.5 and 13.45. So pretty happy with it. It's a nice device. Really, really nice device. I cleaned it all up. The 955 tube is in it. I did order another one on eBay, brand new stock, just in case. I don't know how many hours. I did look at the service manual. They said that tube's only good for a couple hundred hours. Don't know what they were talking about, but so there you have it. It's kind of a useful little tool. A nice, nifty little package. I'll have to work on this one coil here It seems to be out of spec here, this one here. We'll turn it up some. He's reading about a megahertz high, but maybe he's not even worried about it. So there you have it. See you later.